Hello everybody, here we go. We're going to be factoring. I'm getting these problems from the factoring packet 1, which is on our website. You'll find it right here. Okay, so on the polynomials tab, coming down, right, you got your polynomials tab, and then you have all the resources here. And if you scroll down to the very bottom, I threw some extra worksheets on here. It says more factoring practice. And I'm looking at this one that has the 9.1 study guide and intervention. And there's tons of factoring problems in here as well, aside from what's in the workbook. All right, but here's the first one here. So in this packet, this is going off one of the lessons. All right, so this is setting the factors equal to 0 right before factoring. Okay, so if we were just having these equations and you have x times the quantity of x plus 3 equals 0, and it's asking you to solve this. All right, so there's two factors here. If you just think about any two numbers, a times b equal to 0, well, if a is 0 and b is 5, then 0 times 5 is 0. Vice versa. If b is, let's say a was 7 and b was 0, then 7 times 0 is also 0. So when we take that into consideration, okay, this x is one factor. This quantity of x plus 3 is a second factor. So when this factor here is equal to 0, then the entire equation will equal 0. And when this factor here, x plus 3 equals 0, then again the entire equation will equal 0 as well. Well, this one's easy. The x, well, when x is 0, well, if I plug in 0 here, 0 times x plus 3, I don't even care what x plus 3 is, but if x is 0, then this is 0 times 0 plus 3, and I will get 0. And what about here? What does x have to be here to be 0? Well, if you do a simple subtraction here, you get x is equal to negative 3. So if I took the same equation here, and rather than plugging in 0, and I plug in negative 3 in for x, okay, so I'm just going to erase this. Okay, so if I replace this with negative 3, then here, get rid of that real quick. Here I'm going to get negative 3 times 0 equals 0. So when x is 0, the entire product is 0. And when x equals negative 3, the entire product is equal to 0. Alright, so there's two ways for this product to equal 0. Let's take a look at the next example, number 2. Alright, when does this product equal 0? Well, when 3m is equal to 0, that's when m is equal to 0. So let's plug that in. So when m is equal to 0, so 3 times 0, so that's 3m times 0 minus 4. This should all equal 0. Well, 3m is 3 times 0, which is 0, and 0 times negative 4 is 0. Okay, so when m is 0, the entire thing is 0, check. Well, then there's another factor I'm going to consider. When does m minus 4 equal 0? Well, m minus 4 equals 0 when m is equal to 4. So if m is equal to 4, then I have 3 times 4 in parentheses times the quantity of 4 minus 4, right? So all I did right now was plug in for the m's, right? I plugged in 4 for both m's. 3 times 4 is 12. Inside my parentheses I have 4 times 4, which is 0, and 12 times 0 is 0. So there's two ways that this product will equal 0. One option is when m equals 0, the entire thing will equal 0. And when m is equal to 4, again, the entire product is equal to 0. Alright, so going a little bit above and beyond in these two problems, right? You don't have to do all that. You could just set each product equal to 0 individually and just solve r. So add 3 to both sides. So r is equal to 3. So when r equals 3, the entire product will equal 0. Cool. Subtract 2 from both sides. When r is equal to negative 2, then the entire product will equal 0. All right, so there's two ways to get to 0. When will this function or when will this product equal 0? Two different methods. Okay, so there's 3 quick examples of how to get these products to equal 0. All right, so now if if we move further into that packet, actually, if you move further down on that same page, just a couple more examples here. All right, number 10. So when will this equal 0? So if you notice that the other ones in the previous problems was equal to 0, is equal to 0, is equal to 0, right? Great. Is this one equal to 0? And the answer is no, right? So what I want to do first is I want to bring everything over to one side of the equation. So I'm going to bring this -6 over. And remember, when you take a term and you bring it to the opposite side of the equal sign, it takes the opposite sign. So this is 12x squared plus x equals 0. Now, this is already in a factored form. This is in factored form, and this is in factored form. This one is not in factored form. Okay? There's a square term here and an x term here. So what I want to do is I want to ask myself, what can I divide out of both of these terms? Right? What does 12x squared and 6x have in common? Let's start with the coefficient. What does 12 and 6? What's the biggest number I could divide both 12 and 6 by? Okay, and the answer is 6. I can divide these both by 6. Okay, so I'm going to put this 6 here on the outside. And whatever's left is going to be inside my parentheses. So 12 divided by 6 is 2. Plus, and 6 divided by 6 is 1. One more thing here. I have x squared and x. What can I divide, or what can I take away from both x squared and x? And I can take 1x or divide 1x out of both of these. Well, I'm going to put whatever I'm dividing out by here on the outside of my parentheses, and that leaves me with x to the first, and my x's go away here. So 6x times the quantity of 2x plus 1. I can verify this. Okay, so what is 6x times 2x? And that's 12x squared. And what's 6x times 1? And that's positive 6x. And that should bring you right back to your original as a quick verification. Okay, so let me steal this piece here. Right, so 6x times 2x plus 1 equals 0. So now this is in factored form. And now I do the same steps I did in the previous examples. Right, I take this first term, or first product, the first factor, and set it equals 0. So divide by 6, x equals 0. One answer. Take the second product here, so 2x plus 1. When does this equal to 0? Subtract 1 from both sides. 2x equals -1. Divide by 2, and x is equal to -1/2. Right, so this whole product, number 10, will equal 0 when x is 0, or when x is equal to -1/2. All right, number 11. This one's already in factored form for us. I'm going to take this first product here, so 4a plus 3, set equal to 0. Subtract 3 from both sides. I got 4a equals -3, divide by 4, cross those out, that simplifies to 1a, or just a, so a is equal to -3/4. Set the next one equal to 0, so 8a plus 7 equals 0. Subtract 7, 8a equals -7, divide by 8, and a is equal to -7/8. All right, so this is finding the zeros when you already have your polynomial in factored form. All right, one more time, number 12. All right, so this is similar to number 10. Okay, so I'm going to keep my 12y squared term positive. It doesn't matter what you do, but I'm just going to rewrite this as 12y squared equals 8y, and there's no difference between writing that. Okay, and what I'm going to do is bring everything over to the same side. So I'm going to bring this positive 8y to the same side as 12y squared. So I have 12y squared minus 8y equals 0. Alright, so first I just flip the order, right? Doesn't matter. 12y squared equals 8y, or 8y equals 12y squared is the same thing. Now I just took this 8 positive 8y and I brought it over to the same side as the 8y squared. So you cross the equal sign and you take the opposite sign, right? Or you could think about subtracting 8y from both sides. What does 12y squared and 8y both have in common? Right? What can I divide both of these by? I'm going to start with 12 and 8. Biggest factor is 4. And y squared and y to the first, the most I can factor out is 1y from both of those. So I'm going to factor out 4y from both of those. And what will I be left with? Well, 12 divided by 4 is 3, and y squared divided by y is y, minus 8 divided by 4 is 2, and y divided by y is just 1. So, equals 0. Now this is in completely factored form, and now I take each factor and set them equal to 0. When does 4y equal 0? Well, you could take the step, and you could just say, well, when y is equal to 0, 4y is equal to 0. And when does 3y minus 2 equal to 0? Well, add 2 to both sides. 3y is equal to 2, divide by 3, divide by 3. Y is equal to 2/3. Alright, so in this portion of the packet, or in this section of the textbook, they are giving you the polynomials already in factored form. And they're asking you to find the zeros of the function. Right? This is finding the zeros. Right? Which numbers will make this function equal to 0? So this is finding the zeros in factored form, setting each product equal to 0, or each factor equal to 0, solving for it, and you're getting currently you're getting 2 factors that will make this whole function equal to 0. You can have more depending on the function, but in this, all these are quadratics. Okay, and we will soon see how to get our polynomials into factored form. Right, so these are already factored. Finding the zeros. Next lesson, let's take the polynomial, factor it, and then find the zeros. All right, see you soon.